day and welcome in this video presentation. We'll uncover the world of the gas law and we'll focus on the one of the most fundamental laws of the chemistry, which is the Boyle's law.
But before we jump on our main topic, we'll discuss first gas law. What is a gas law? Gas law describes relationship between pressure, volume, temperature, and amount of gas, and there are 6 primary gas law, which is Boyle's law, Charles law, Avogadro's law, Gay-Lussac's law, the ideal gas law, and combined gas law. These laws are crucial in explaining how gases behave under conditions that differ.
And now, let's focus on the Boyle's law. It's one of the most well-known gas laws. Boyle's law states that pressure of a gas is inversely proportional to its volume when the temperature is kept constant. In other words, when the volume of gas decreases, its pressure increases, and when the volume increases, the pressure decreases.
This relationship can be expressed with the formula P1V1 equals P2V2, where P is pressure and V is volume. The key takeaway is that pressure and volume are inversely related. Let's solve a problem using Boyle's law. If a gas has an initial volume of 4 liters at a pressure of 2 atm, what will its pressure be if the volume is reduced to 2 liters? Number 2. A gas has an initial pressure of 1.5 atm and occupies 6 liters. If the volume is increased to 12 liters, what will the pressure be? And now let's try solving it. Our given is V1, V2, and P1. Our V1 is 4 liters. Our V2 is 2 liters. And our pressure is 2 atm. Since it is just only one pressure, our unknown is P2. And now, the formula P1 V1 equals P2 V2. Let's solve it by using our solution. Copy the P1 to atm and V1 4 liters. Copy the unknown, which is the P2, and V2, which is 2 liters. You just have to copy it and cancel. Times the 2 atm to 4 liters, and the result will be divided by 2 liters. And our final answer is P2 equals 4 atm. And now, let's try another example. Our given is V1, V2, and P1. Our V1 is 6 liters. You just have to copy it. And our V2 is 12 liters. Our pressure is 1.5 atm. Since we have only one pressure, our unknown is P2. Our formula is P1 V1 equals P2 V2. Let's solve it using our formula. Our P1 is 1.5 atm and our V1 is 6 liters equals, copy the unknown, which is P2, and V2 equals to 12 liters. Bring down the 12 liters, both sides, and cancel it. All you have to do is times the 1.5 atm to 6 liters and the result will be divided by 12. And our final answer, which is P2, is equals to 0.75. And now, let's talk about the real-life application in Boyle's law. The scuba diver jumped onto the water and lowered himself under the surface of the water. He feels a little pressure in his ears, so he plugs his nose and swallows to equalize them. The reason he's feeling that pressure is the surrounding water pushing in on his ears, which causes even more pressure put on his ears. As the pressure increases on the outside of the ear, the air inside gets squished and the volume inside decreases. Here are the other examples of real-life application in Boyle's law. Small balloon in a thread. We put the balloon inside a syringe. The balloon does not compress when the piston is pushed as the air escapes from the front, keeping the atmospheric pressure the same. The balloon compresses when the piston is pushed and the opening in the front is blocked, increasing the amount of atmospheric pressure.